I mean, like she lies that she is all right, we're going to start quiz review today. Let me kind of walk through the calendar here. So today we're going to do worksheet 1. Whatever we don't finish in class, you guys will do for homework. So I'll check. Okay. And then tomorrow we're going to do worksheet 2. It's all in your packet here. And then you'll finish worksheet 2 for homework. And then next Wednesday after break, we're going to do worksheet 3. Okay. I'm not going to check worksheet 3 for homework, but I will have help sessions Friday morning, sorry, Friday afternoon, Wednesday afternoon, and Thursday morning. All right, we're going to work on worksheet 1 today. If you guys can turn to the, I think page 5 here, I want to kind of summarize a couple of formulas that we're going to need to know. So first is integration by parts. Usually we can identify integration by parts problem when you see different families of functions being multiplied to each other. Doesn't mean that it's always going to be the case. Sometimes it's use substitution, but on the quiz, I'm testing you for this specific content, so you can expect integration by parts. Now, within integration by parts, there are 2 different ways of doing it. One way is using this integral formula, f prime g, integral f prime g equals fg minus integral f, integral of fg prime is equal to fg minus integral of f prime g. But we're forced into this original integration by parts formula if a log or natural log is involved, because we're not able to use tab method if logs is in the expression. So that means your f is going to have to be your log, and then whatever is remaining is going to be your g prime. We can only use tab method if no logs are in an integrand. Like for instance, tab method will be good if it was integral of x cubed cosine of x dx. Right now we can assign f to be f x cubed and cosine x to be g prime, and go down our column and multiply diagonals. Okay, improper integral. Anytime that your limit is approaching a bound that is infinity or a point of discontinuity, if there's a vertical asymptote that is getting either in between your bounds or right at the bounds, we have to involve improper integrals. We have to involve limit as b approaches infinity or b approaches the asymptote, and then we do the integral rules that we normally would, and then when we evaluate, we have to decide, okay, is this expression going to go to a real number? If it does, then it converges and we have our answer. If it goes to infinity or negative infinity, we just say that our integral diverges. We don't have to specify infinity or negative infinity, just have to say that it diverges and show the work that leads us to it. Right. Partial fraction decomposition. This is good for whenever we're trying to break down a rational function into separate fractions with its own linear factor that will allow us to split up a messy problem into smaller ones. And we use the cover-up method. And usually what happens is when you do that, you're able to split them up into something that you can apply 1/u du for natural log rule. Okay, Euler's method is kind of like an extended linear approximation. We create a table with x, y sub 0, y prime, and then our y equals y sub 0 plus y prime delta x. We find out what delta x is, and then we're just going down the line and gathering more information. until we get to our approximation. Logistic differential equation is going to come in two forms here, either with the L inside the expression or parts of L being pulled out. Okay. Arc length formula. We did that yesterday. And then L'Hopital's rule, you'll see a problem where you have a variable raised to a variable. You're going to have to set y equal to that equation, use logs to bring that variable down, and then manipulate the expression to get it into numerator and denominator and show that you're getting a 0 over 0 or infinity over infinity, and then evaluate the limit of that expression of f prime over g prime, reevaluate, get down to a number, and then solve for y, because there's still a natural log on the left side. So we'll do a couple of those. Okay, so these are what we're going to be working towards as we prepare for our quiz. So let's start with number 1. Okay, what type of problem, what type of concept is this? What method do we use?
IB.
Yeah, integration by parts. And can we do tab method here? No. No. Okay, so what's going to be your f function?
Natural or formal.
Yeah, that's like 4x, and then your g prime will be.
Yeah.
Okay, right. So try that. Yeah, so your natural log is always going to take priority. Okay, if natural log is paired with anything else, that has to be f. Okay. It can't be the g prime. Yeah, so basically, if you see natural log, it's always going to be f. And if there's no natural log, then your algebraic or your polynomial will be your f. Now, when you use integration by parts, there's always going to be the first portion that is completed and the second portion that remains incomplete. So we have to resolve the second integral expression there. But you're always going to start off with f and g prime. On the f side, you're going to find f prime. On the g prime side, you're going to take the antiderivative, get to g. And it's going to be fg minus integral of f prime g. Okay. The right side, the second term is resolving using power rule. So let's do some cleanup here. This is the same thing as integral of 1/3 x. And then once you apply a power rule for that. Okay. So whenever you go through integration by parts, the first portion is complete. The second portion still needs some additional work. Any questions with 1? Number 2, integral from 0 to 6 of 1 over root 6 minus x. What do you notice about the bound? Yeah, there's discontinuity, right? That denominator is kind of giving us a hint as to what's happening. Where's the issue? 6, right? You know, there's a discontinuity at x equals 6. So we can't reach 6. The best we can do is we can approach 6. So your graph is going to be between 0 and 6. So sorry, to the right of 6, to the left of 6. So we're going to be approaching 6 from the left side, right? Because the graph is going to be to the left of 6. Okay, so once you have this set up, then you're going to basically approach this problem like you normally would any integral problem. In this case, looks like we have to go through use substitution, right? Get it ready for power rule. Once you take the antiderivative, then you can evaluate your bounds from plug in the b, then the 0, and then you just have to look at things carefully. And right, if I can plug in 6 into my antiderivative, then see what that gives me. If it's still undefined, then maybe test 5.9 and basically have to convince ourselves, is my value that involves the discontinuity, is it going to 0? Sorry, is it approaching real number or is it approaching infinity? If it's approaching 0, then typically that's going to end up allowing us to arrive at a converging value. If it goes to infinity or negative infinity, we can just stop the problem and say, okay, diverges, and we stop. There is no integral that exists.
I wouldn't know if it's R10 and when do I know if it's like linear decomposition? Or at least how do I?
Yeah, it's a question. I think number 5, we could use arctangent because of the fact that we're able to complete the square. So I think some problems may have multiple solutions, but the ones that I give you will be, you can expect it to be a linear approximation problem. But on the AP exam, if you see a problem with this on the AP exam, it'll be multiple choice. So you look at the multiple choice option, and that should help give it away. Right.
I don't think this will be a free response, right?
No. Or if it's free response, it'll be on a BC exam, it'll be something involving linear approximation to get to where you want to be. Yeah. I know, so it's like kind of confusing because it looks like there's 2 solutions that could look wildly different from each other. Actually, you know what? To answer your question with number 5, if we try to do arctangent, we're going to get stuck actually. So let me show you why that's the case. It's going to end up giving you a negative. That's not going to fit my arctangent rule. It's got to be a squared plus, or u squared plus a squared. This is a negative. So if we try to do arctangent, we're going to get stuck not being able to fit the rule that we want. This doesn't fit integral of u squared plus a squared. So actually, this does break down with arctangent. So we try to do arctangent.
You can't discriminate.
Yeah. Okay, so walking through the steps for number 2, we recognize this as a u substitution problem, and we can bring that parentheses up to the top, u to the negative 1/2. The derivative will produce a negative 1. So as we go through power rule, we got to make sure we keep track of that negative 1. We go through power rule. Once you go through power rule, replace the u back in terms of x, then plug in your upper bound and lower bound. Always start off, even if it's one-sided notation, always start off by plugging in the whole number first. See if that gets you a real number. If it does, then just leave it. So here, if I plug 6 in for b, this leaves me with 0. So that's great. That we can work with. And then plus 2 root 6, that's a real number. So our integral converges for number 2. Now, if for some reason you plug in 6 and you're getting something undefined here, then I would play with 5.9, 5.99 and see if that will help you decide what's happening to your fractional value or to your expression. Okay, number 3, we have an option here. We could do what or what? Yeah, we could do tab method, or we could do the IBP. Whenever I see something where I can do tab method, I prefer it, even though this is not a nested one. But we do need to make sure that it's good to know both methods, right? The tab method can help save time for nested integration by parts, but we also need the original formula because we need it for if natural log ends up being one of the terms in your problem.
question is, are there problems where linear decomposition in R can work the flow?
I want to say no. I think it's going to be either one or the other. Because if it factors out, it should. Now that I think about it, if it factors out, it should just be partial fraction. And if it can fit under arc tangent, it'll have to be very specific. It has to be both a u and a squared being both positive.
Also, do I have to show my work for the u sub?
No, you don't have to. Yeah, if you understand, oh, it's just a 1/5 every time, then yeah, you can just go directly from here to here. Don't have to show your substitution. I'm showing it because I want to make sure that students don't treat it like chain rule for derivatives and multiply by 5 instead of 1/5. But yeah, you don't have to show that step if you don't want to. Okay, number 4, though, we definitely should use what? That, right? That x cubed is gonna require multiple integration by parts. So number 3 is not necessary to do tab method, but number 4, you really save a lot of time using tab method. But again, we got to be careful with that u substitution that is causing a coefficient to come out of the antiderivative each time we do integral of e to the 2x.
Number 6 on the AP exam, if it's non-calculated, like how do I know the graph behavior?
Yeah, it's a good question. I think right now it's just I want to give you the calculator so that you can kind of get used to the graph. And so yeah, so arctangent does feel a little bit like out of the blue, but if arc trig shows up on AP exam, it's usually arctangent. Yeah, but this is what arctangent graph looks like, and typically if there's usually at least the ones I've seen in terms of having knowledge of an arc trig graph, it's the arctangent graph that shows up the most. I haven't seen the arc secant and arc sine graph playing a role in AP exams in terms of knowing what the shape of the graph looks like. So. Yeah, if you think about the tangent graph, has vertical asymptotes at negative pi/2 and pi/2. So if I flip that off to the side, I know that my vertical asymptote will turn itself into horizontal asymptotes, and the graph will kind of have this positive slope feel to it. So it's just basically taking this and kind of flipping it sideways. Okay, but first, number 5, we use the cover-up method. Well, first, we recognize this as linear approximate. Oh, sorry, we recognize this as partial fraction decomposition because we know that we can factor that denominator. We can split them up into the sum of 2 fractional values, which will make it a lot easier to work with because we can't quite fit this into use substitution or any other method. So split this up. Identify the factor in each of the fractions. So if I start with x minus 2, I'm going to cover up the x plus 2 in the original fraction, in the original expression, replace the negative 2 into the entirety of the fraction, and see what that gives me. Here, if I plug negative 2 in for x, I get 1/2, 1/2. So that's my a value. I can replace a with 1/2. Repeat the same thing for my b. X plus 4 is equal to 0, therefore x equals -4. Cover up x plus 4 and replace the x in for 4 and 4, -4 and 4. Thank you. And have that right. Okay, we have our a value and our b value, so now it should feel like a much easier problem. They're just going to, at least, from the ones that we do with linear partial fraction decomposition, it's always going to end up being natural log that allow you to get to your antiderivative. Just be careful that sometimes your u value may require a bit more attention, especially if there's a coefficient that's going to come out of u substitution, and you got to keep track of that coefficient. In this case, though, the x plus 2 and x plus 4, they both produce derivative of 1, so they'll just be quick and easy natural log absolute value of u. Okay, number 6, we definitely know that this is a improper integral. It's not hiding like in like a problem where you gotta find the vertical asymptote. This is obviously approaching infinity. We have to involve limit as v approaches infinity. So set this up. This is gonna have to be a arctangent rule here, because I have a squared plus u squared. Take the antiderivative. Then I can evaluate my upper and lower bounds. 1/3 arctangent of b over 3 minus 1/3 arctangent of 0. Arctangent of b over 3, if I replace b in for infinity, this is arctangent as we approach infinity. And that's going to be pi over 2, basically saying tangent of what theta value will give me infinity, and that's pi over 2. Right? Because we know that pi over 2, there's going to be. Here, we can also ask the question, tangent of what theta value is equal to 0? Tangent of 0 is equal to 0, so that's how we know. Also, we can, if we know what the graph looks like, we can also tell that our tangent of 0 is 0. That does converge. We do get a real number out of that, so pi over 6. Okay, number 7. Remember, you have to recall your logistic equation form and match it to that form and pull the L, which will be your limiting value for your carrying capacity. Euler's method, I think, is pretty easy, but it just requires you to know how to move through your table. So once you know what every column represents, you're just working through that column until you eventually reach your y value for a specific x or y. No, it's just,
the-
yeah, just the examples that I found end up being one.
Okay.
Ava, page 15 in your packet, with the solution key for local, there's one that didn't end up being that, so, but yeah, this seems like love, it does end up being 0 and ends up being 1.
So you said like 1 to infinity, like is that indeterminate?
That's indeterminate, but it's not in the indeterminate form that we can use L'Hopital's rule for, so we gotta force it into use log differentiation to get it into numerator over denominator. So yeah, technically they're indeterminate form, but not in the form that L'Hopital's rule can be applied, so that's why we have to do all that rearranging.
I don't know if someone already said this, but is there a way to know like early on if it's an arc trig integral, if it's the division, the partial fraction?
Yeah, if you can factor it and break it into separate parts, then it's gonna be partial fraction. But if it fits into that a squared plus u squared, it'll be arctangent.
So I could factor that into x plus 3x minus 2.
No, we can't do difference of squares unless there's a minus sign,
It's like.
right? I mean, if we factor it, we gotta involve imaginary unit I. We can't factor it that way,
Okay.
so, yeah.
Right, so
But yeah, so yeah, if you can factor it, arc, if you can factor it, partial fraction. If you can't factor it, then it's arctangent.
Okay.
But yeah, they look a lot alike because you got degree 2 below and degree 0 up above.
so if I put it into like the arctangent like form. With the
Yeah,
square-
then we know that's what we want to use. Okay, so hopefully you guys feel pretty good about the topics that we've already done. I mean, we still have we have tomorrow class period and Wednesday class period, so you guys should feel really good when we get to our quiz day next Thursday. So tonight, your homework is just to finish off worksheet 1, and I'll check that for homework tomorrow. Okay? Have you folks?
Wait, I'll leave your own slides.
And